Hello, everyone. I'm David, as it probably says on this slide. I'm a PhD student here at UTSA. I am currently working on some deep learning, robustness, and artificial intelligence, specifically in computer vision. And today we are going to talk about deep learning and kind of give a broad overview and workshop and kind of give you all the tools you need to start on the problem and hopefully go from there. I am one of those people, if you want to ask a question during the middle of the thing, go ahead and stop me. If not, I'm definitely going to leave time for questions, and we'll stick around a little bit after for anyone that wants to ask there. Cool. So let's start off with that, the best slide. Challenges in deep learning. So I'm sure as you've all heard, deepfakes are pretty popular, and artificial intelligence, deep learning, those are all buzzwords that are flying around, and there's some really cool stuff going on. Tesla and automobiles, they just had recently their robot has gotten quite far in development, and we've gotten really good deepfakes. But how come we can't do some basic stuff, like recognize a banana if something's just on the side of the screen? It should be simple, and every human can do it, but some reason machines fail. And so hopefully we can kind of talk about what that is, but let's start with some background. So you'll kind of hear the terms AI, machine learning, deep learning, all used together. They don't actually mean the same thing. Deep learning, so we'll start with the top level. Artificial intelligence, the goal is to make human-like behavior with artificial intelligence, right? That's robots, machines, simple stuff. And then as we get further, we'll get into machine learning, which is a little umbrella underneath it. So that focuses specifically on devices' ability to mimic and learn. That will take lots of data, and people kind of hand tune it towards things. So you'll see hand-labeled features, stuff like that. Very, very detailed. And then finally, we have deep learning, which is my field. That's kind of where we said, I don't want to do the work. What if I make the machine do the work, right? I just give you a bunch of pictures, tons of data, and you tell me what's the difference between a dog, because I don't want to teach you. You should learn yourself, right? That's the ultimate goal of every teacher, just be able to talk, and through osmosis, everyone will be able to understand it. So it turns out AI is pretty good at that, both data and visual data. So here are some examples of AI used in the field, kind of. So I think over here, we've got some MRI images that they use models to help identify breast cancer, some other things, which is really cool. They recently developed an artificial intelligence for space, be able to detect different galaxies, what they look like, where they could be if they're expanding. And then finally, there's the more political side where you can kind of predictively guess some things and try and make decisions based off of that, who's winning, who's not. All really, really cool stuff. So how did we get here? How did we go so far in such a little amount of time? Because deep learning and that hasn't been around. Well, we started off like we do everything else. Math, everything. We always start off by hand. No one ever lets us use technology at first. They just say, hey, let's do everything by hand. So we'll take this example of a squirrel, right? And let's say I want to give it to a computer. Back a couple, 10, 20 years ago, they actually used to hand math out all the kernels to try and pull out all the features from it, which you can guess is a very math-heavy, intensive thing that is very subject to whatever you're going to get, which can make it really hard. But the ultimate goal is the thing right over here, is how do you think we learn images? What do y'all think is your best guess? If I were to take this newspaper, what's on it? Just text. And then if I were to ask more detailed questions, what would you give me? Like, what is the title of this newspaper? Paisano. Okay. What do you think this newspaper is going over? Right. It gets harder and harder questions, but you start with the simpler ones, right? Lines. text, shapes. If it's square, it's black and white, must be somewhat a newspaper. And then you kind of look towards the titles and the different pictures and you figure out, oh, that could be this type of paper. Same thing, your brain processes shapes, lines, and then it will slowly build out those higher and higher level features until you've created the whole image. But doing things by hand is no fun. So we went to the next step. Can we have an architecture learn it for us? Can we say, hey, can you learn all the different types of features? So we'll start with the lower one, lines, and then we'll get into more complex shapes, and then patterns. These are what are known as CNNs early days. So you'll notice this is MNest, a very popular tutorial data set where all you do is black and white handwritten digits, 0 through 9, that's all it is. So you kind of take these really, really small inputs, feed it to your network, ton of math happens on this side, and we spit out, it's either a 1, 2, 3, all the way to 0, which is really cool. Even this little application you could use for math, right? Identify numbers, slowly build things out. This was like 20 years ago. So where are we now? We've kind of gone a step further into generative models where we can now generate data and various other things. So there are 3 different kind of parts. The first one is the dog. The dog is doing something called neural style transfer. So on the left, you'll see there's a picture of a dog, and right next to it, I believe that is a Van Gogh painting. I am not an art expert. And then we can take those and combine them for the ultimate art. And most recently, this has become a development topic of the art world because that same idea just won an art competition. And now it becomes a question of who won? Did the person that made the model? What about the artist that fed the model the data? It's kind of interesting. Same thing with deepfakes. Right underneath it, you can see there's some deepfakes as they slowly progressively get better. And now if I put a deepfake actor, who gets a credit? If I put deepfake Bruce Willis, does Bruce Willis get it? Is that how we get another Die Hard film? Who knows, right? They're really interesting ethical questions, but we're getting there. And these are things we have to talk about. And finally, the hot topic. What do you think the picture on the right is? Right, yeah. Autonomous vehicle. What do you think it's doing? Obstacles, right? This is what we call segmentation. It's taking it and identifying where can I drive and where shouldn't I drive. Probably shouldn't drive on this side street with the mailbox unless you're really feeling it. Otherwise, probably stay in the road, right? Super hot topic, but now there's also some kind of moral questions on when do we trust enough to drive? Because there are some people I don't even trust to drive. But are machines held to the same standard we are? So now we get here, the current state, which is, there's a lot going on in this picture. But basically, we've gotten really advanced between CNNs, which is the top left, to the new hot topic of, well, semi-hot transformers, which takes a ton of data and kind of processes it in blocks. And we have tons of data sets, ImageNet, Coco, Kitty, everything labeled, all for the sole purpose of solving a task, which is really, really cool. We're getting into a really cool space right now. So we're doing it, right? We solved all of the problems. No. You may have seen this. What's sad is this thing can probably bring the most sophisticated model to its knees because we can't identify the difference between a blueberry muffin and a chihuahua, which is oddly terrifying, but also I sympathize. Some of those do look like blueberry muffins. Yeah. So why do y'all think this is? Why do you think it has such a problem doing this?
There's very similar features, like visually looking, like as a person. A lot of these images have like similar looking characteristics.
It only identifies major features. It won't determine that there's like a liner on the something. It won't really tell the texture difference.
Okay.
I was going to say once they all look the same once it has the image processing.
Yeah, they all look the same. They're all kind of very similar in some aspects. And at a quick glance, you might actually mistake a chihuahua for a thing, which is scary. Probably don't want to try and eat one of those. That would be bad. So I'm going to kind of talk about some open problems that there are right now in our field. The first is the easiest, image recognition. I give you a picture of a sheep and a dog, and hopefully you can tell me with some level of confidence if there's a sheep and or a dog or a cow in there, which in this case, there's probably not a cow. And then we get a little bit further, semantic segmentation. What if we could separate the objects, right? Let's get all the goats and the dogs. What's the problem with the top right one? They're all together, right? Which goat is where? How many goats are there? Where do they stop? So this is where object detection kind of comes in and says, okay, I want to identify all the different things. What's the problem with object detection, though? Kind of overlap. And that's kind of not how the real world works, right? You can't just put a box around a thing because, I mean, the table, the monitor, they have a clear stopping point, right? You don't want to put a whole boundary around it. And so finally, we have the instance segmentation where you can kind of piece all these together. But that is a very hard problem because you have to teach the thing how to do it. We do. But then now we have to label all of our data just like that, which is very tedious, time-consuming, and kind of prone to human error, which is fine. But, and I'm sure with more time we will get there. Whereas for right now, convolutional neural networks, and even to a degree transformers, not as much, are really sensitive to textures. So on the right over here, you'll see this abomination of a picture where you kind of blend all the textures together. And you guys, what is in the picture? There's a dog, right? Computer can't tell you that. It will be way too confused on what is going on. There are too many shapes, too many lines, too many colors that are not supposed to be there. But we can do it, right? And then if I told you, you look to your neighbor and explain why that's a dog, that's a really hard thing to do. You just be like, well, there's a dog, can't you see it? And then you'll outline it. Then you'll try and get rid of some of the colors. It's not human-like right now. And that's what my research is kind of going towards, is how do we get more human-like models? How do we get those explanations built into them? So here's a picture of a bird and lots of different types of anything, right? So let's take autonomous vehicle driving for a second. How often do you drive and then there's rain? Or how about snow? Or how about some guy swerving into your lane that shouldn't be? I mean, it's Texas after all. But these are all things that could happen. Camera blur. Thankfully, I'm hoping the camera back there doesn't have any. I mean, technology malfunctions sometimes. Weather is unpredictable. And if I can't tell you there's a bird in every single one of those on a machine, I don't know if anyone's gonna back that machine quite yet. But it goes further than just visually, because all I've shown you right now is, yeah, okay, I'm sure I might mess up some of them. If I like the snow, there's a lot going on. I might miss the yellows in that color. It's a little bit worse than that, though. So this is what we call an adversarial example. The idea is we take some noise, mostly hidden, and we add it to our image of the pig, right? Bless you. So let's take the right one, right? Do you guys see any difference at all between the left and the right? No, those are both pigs, right? If I gave you both of those, pigs. But the model is convinced the thing on the right is a new airline business called Swine Air Flights. I just made that up. That's probably not a thing. And that's weird, right? It's kind of hard. But it plays into the optical illusion kind of thing. I can give you an optical illusion. You'll see one thing, someone will see the other. You see, there's a lot of kernel math going on in the background. So they'll take square by square and say, oh, well, mathematically, this thing on the right's closer to an airline than it is a pig. That's terrifying. I don't want my pig to be an airline. It doesn't seem great. You're like, well, okay. They'd have to get the picture before and then do all that stuff. Well, no. See, I can just make a sticker and then put it on a stop sign and say, now we get to go 30 miles an hour instead of a stop. Which, again, some people might want. I am not one of those people. Or the one on the left where I put the sticker on the table with the banana and it completely changes its output. In fact, I don't even need to go as far as the sticker. I could take that banana and put it on a washing machine, and I'm pretty confident it wouldn't know what a banana is. Because it has no idea what a banana actually is. It's just seen thousands of examples, and most of the time, a banana is probably not on the washing machine. So, now, I just talked about all the bad things, which is, you know, that's not usually how you want to start off. I just want to set the precedent. But there's a lot of cool stuff that's going on right now. How much do y'all follow the current news and what's going on, especially with Meta and Tesla? Sorta. Okay, so today I want to talk about one of their cooler applications. There's a couple, I think there's two that I really want to talk about. So let's start with the basics. Tesla's semantic driving. We're getting pretty good. You know, got trees. This actually came from one of the, I think, graduates in the Vail lab. Works on a model to segment out some of the road data sets. Now, it's not perfect, but it's a start, right? It's how we slowly start learning, and autonomous driving is real big. I wish I could show you stuff from Tesla, but I'm not that important, so they don't give me access to that kind of stuff. But what they do give me access to is what they give everyone, stable diffusion. This is a really cool thing that just came out this year. And it is a model that can take a line of text and then try and generate an image from it. So on the right here, you will see the prompt was a photograph of an astronaut riding a horse. And how do you think it did? Yeah, not bad. It's better than I can draw. So now these aren't these are generative models. They created these pictures didn't exist before you typed those words in there. So it did pretty good. But, you know, I'm at a Datathon, hackathon. If there's one thing that's important is some people are really good at showing you all the good sides and ignoring all the bad sides, right? So I figured, why don't we test them? Which I believe, oh. All right, fine. All right, this is where we learn I'm not spelling, but that's why autocorrect is a thing. See, what do we want? Big businessman, what? Okay, running an airline. Airline. Okay. This will be the longest 45 seconds of anyone's life as they really try and think about all the different ways that that can look. And, you know, I, opening Pandora's box, just typed in whatever. So this is an open model right now, as you can see, that lets you practice with it. They also gave the code. So if you wanted to download it and run it yourself, you can do so.
Who did this?
This is Hugging Face, which they branded themselves as Stability AI, kind of a subsection branch under them, I think. I'm not totally familiar with the company. You know? Man, we got some of it. It could have been worse. We could do, let's see. Hold on. Before I open that, I'm going to do this. So in a minute, I'm going to kind of talk about high level what's going on back behind here. In no way do I expect anyone to like go and we're going to be able to do this by the end of the workshop. I just wanted to, it's a 24-hour Datathon and I want to give everyone a break and remember that this is kind of, there's a lot of neat little things that you can do with this. And I do have another one that kind of will show that, which we're almost there. And I actually have no idea what will show up on the other side of this. This is, again, why you never do this in a live thing, but I like to live on the edge. So, again, I gave this to someone. I gave my whole slides to someone, which will have the link to this. So you guys can play around with this and kind of see all the different stuff and some of the other stuff that I will show you on kind of where to get all of that. But what's going on in the background is probably a little bit interesting. But what if we went a step further? And I took that same sentence and now we make it into a video. And that's exactly what Meta AI is doing, or formerly known as Facebook. So this is the fun part because I know what prompts there were to take these, but now I just get to ask the room, what do you think were the prompts to get some of these? Superhero, no. Horse drinking water. Honestly, it could be. Speaking of which, I'm excited to see what comes out of Bob Ross MS Paint. So, same idea. We take an image or a text, and we send it through, and we say, hey, make a portrait. Now, we got a little too meta there, where our teddy bear is now painting a picture of a teddy bear, but it works. Although you might want to get it checked out. If you see a teddy bear painting a picture of a teddy bear, you might want to see if it's real or not. So what's going on? High level, we will take our input text and we will send it through a bunch of decoders, which is a fancy way of saying we're going to break it down into features, words, things that it can understand in a space. And then slowly, as we get further and further out, we'll slowly build out the frames, and then we'll make those frames look better. It will start out choppy at first, and then we'll kind of smooth the frames out. And then eventually we get the final thing at the end, which is the nice little video. So what do you think the next slide's going to be? Sound. I wish I had sound. Although, funnily enough, there is now an AI that can take lyrics to a song and put portraits to it. So you can create your own music video without doing any work, which is great.
Can that AI do like celebrities as well?
I don't know if that particular one can, but there are some that can, for sure.
Well, especially with the recent news that what's his name's leaving the Darth Vader role, and now they're going to use AI to generate basically Darth Vader.
Yep, James Earl Jones.
That's pretty scary.
Scary, but definitely cool in some aspects. So I had to do this.
Oh my god.
Yeah. See,
Right now?
we don't always get it perfect. You know, if you say a dog eating an ice cream cone, that's probably not what you imagined, but it is going to be now. And the thing on the left, stitching people together, is kind of terrifying, and there's definitely room for improvement. So these guys have a website as well. They don't have their model available, but they do have some examples, and they have their research paper. So they're definitely a cool kind of thing to check out. Okay, so now we start talking about if I want to get into deep learning, what do I do? Because I'm guessing we're all not Google and have tons of, servers in our backyard just running all the time, which is great. So there's two kind of titans of deep learning, as I would put it. So the guys on the left are Pytorch, and the guys on the right are TensorFlow. You'll hear these two kind of talked about in tandem, and as any true argument goes, no one can agree whether who's better than the other. So it's just an all-out war between those two. So let's kind of go over the different goods and bads of each one. So I want to start with Pytorch. Pytorch is an open source framework that is done by Facebook, Meta AI. The good thing here is it's very Pythonic, I think that's a word, or Python-centric, very much based in Python, and kind of integrates with that really well, which is really nice. They have a super active community. You can forum search basically anything, and someone will probably respond to you, and it's not going to be like Stack Overflow where they hit you on the head with a hammer and like, no, just do it my way, right? It's not always great. So they're super awesome. They do have some limitations, however. First one being, like any good data scientist, sometimes you want to visualize your data, see what it looks like, how it's behaving to certain things, and Pytorch just doesn't play nice with visual tools for whatever reason. They're not built in, they're not really designed for that. You can do it. And two, Pytorch is not used in the production world because it's very, well, Pythonic. It's not very industry-friendly code. And on the other side, we have Google. Again, you'll see a theme. They're both open source. But this one, and probably the one I'll recommend to most starting people, although that is debatable, is TensorFlow. They have super easily trained frameworks. Their tutorials are very strict, but cover a lot of ground. They can work with almost any language, C, Python, except probably not Perl. Don't do Perl. That wouldn't work very well. However, being that it can work with any language and is done by Google, it's obviously going to be very hard to figure out what's wrong sometimes. They just kind of tell you words, and those words aren't always English. So, and also, Google just thinks everyone has a GPU in their back pocket, which I wish I did. I'm going to be honest, but super GPU dependent, very good, very GPU dependent. So, which do I choose? How many of y'all have worked with either of these? All right, so we poll the room. Do you go left or do you go right? Left? Okay, so the ones that said left, why? If anyone said left. Okay. That was resounding no. Okay, the ones that go right, why?
It just popped up on YouTube. That was the first thing.
That's fair. Although I think that's cheating, because I think Google also has access to that. And I would show that first, too.
I can be wrong, but can you use Pytorch like with TensorFlow syntax? Or no, wait, I'm thinking about it.
I will get to that. I promise. Anyone else want to chime in? There's not really a wrong answer here. I'm just curious.
I think the language compatibility of being able to use the language that you want. I mean, so far Python has been difficult to work with, so I prefer, I mean, you know, if I need some other options, I don't do stuff like that.
Yeah, I mean, it makes sense. Have you tried to wrangle a snake? It doesn't go well most of the time. Kidding, different Python. I've used both. As of currently, I'm using Pytorch. That is because Pytorch is better if I want to do things that aren't supposed to be done. Part of doing research is figuring out problems that no one really thought about. And you really want an open kind of box to do that in. And TensorFlow isn't always the best, although I've used them. One of my old papers was using TensorFlow, and it's actually up there on a GitHub somewhere in the ether that I'm sure you can find. So the real answer is you use neither of these at the start. You use a subset of them, which is Keras and Pytorch Lightning. See, these are nice little wrappers around these giant frameworks, which are big and scary, that make things a lot easier. Think of them as just a giant toolbox to use your playground. But the toolbox is very nice and easy to work with. There's lots of documentation, lots of other things. I'm not going to say one is definitely better than the other. They both are good. I've used them both. It's whatever you want. Yeah. I don't know where else I was going to that. So the follow-up question is, now I could ask you guys, let's train a network on all these computers in here, and how many of your computers might overheat? That's fair, right? If you really want to warm up a room, it's great, right? Not really a problem in Texas that we have to think about, but you know, if you're in the north, that could be something useful, right? So if you're like me, and especially when you're first starting, you don't have GPUs everywhere. Your laptop's not, you're just kind of getting around. Well, thankfully, there's a couple of options that you can do. First, which I believe someone asked at the beginning, is Google Collab. So obviously, this was built by Google, and it could probably stand to reason that they're probably going to lean towards TensorFlow, being that they built it. But it does work with both. What this is it's basically an online cloud service where you can write deep learning, machine learning code and have Google run all the GPU calculations for you, which is super great because GPUs get hot and all of that. And your computer blue screens 2 days before your presentation, and here you are. But no, never. I would never do that. Anyways, so it's free. There are downsides. Anything with free, it's probably going to be limited, as in it will probably kick you out after 2 hours. But, there's ways around it. You can publish from GitHub, Kaggle, all those other things. Now, I forgot to ask who's from UTSA and who's not, but you know what? It doesn't really matter. So this is kind of what it looks like. What does this look familiar? Does this look familiar to anyone? Linear regression. But I meant the style. Jupyter Notebook. Yeah, I mean, you weren't wrong. I should be more specific with my question, so that was still a good answer. Yeah, this Jupyter Notebook. It's very, how do I put this? It's, if you want to see what you're coding right away, Jupyter Notebook's very good at it, right? You get to type it in, instantly run it, and the visuals are right there built into the notebook, which is super great. Like anything, it might be super bloated, but it's super helpful for visualization and that kind of stuff. Okay, but what if I don't want to use Google Colab and I'm from UTSA? Well, there's UTSA ARC, which actually just got built recently. For those of you that have been around long enough, before this was Shamu, not to be confused with SeaWorld's Shamu, totally different. One can actually run your deep learning model, the other cannot. So ARC, it's a massive cluster where you can do a bunch of computational stuff, data storage, data mining, simulation, modeling, any of that. The caveat being, well, you need a faculty sponsor. They're probably not just going to let anyone walk in and be like, I would like to run this model, please. And be like, who are you? Why do you want to do this? Also, are you sure you're not Bitcoin mining? Because I don't trust you. Fair. So there's a lot of different options in terms of that. So the last couple of slides. And then I'm going to open it to questions to keep it more freeform. Is a semi kind of where I'm from, what it is. So UTSA Vail Lab, which is one of the labs here in CS, Vision and Artificial Intelligence Lab. We're in the second floor, somewhere in a prison cell with no windows. But we're there, I promise. And these are all kind of problems that I've been talking about today that we're looking at solving, right? How do we generalize across all these different problems? How do we make more understandable AI? And then how do I break it? And these have answers, right? Computer vision, semantic segmentation, visual saliency, those kind of stuff. Super cool. Domains, trying to take the cat and dog problem and move it somewhere else. Guess all the different cars. And cybersecurity, who's not us, but it's very important, is how do we break it, right? How do we break it, and then how do we fix it before it's broken? Because that's important, especially if you want any sort of application. And so these are some of the members of our lab, and then the rest didn't give us their picture, so we can't put them on there. So I'm in there. I don't really know why I took a black and white photo, but I'll get it updated at some point. This is run by Dr. Amanda Fernandez. Super cool. Geyer, who is now working at Lannel on some other things, Ethan, and then Chris and Gideon, and finally Zach, who is a CS bachelor student. So you'd be like, why are you telling me all of these things? Well, that's because we need people. We've had quite a few, and then they all graduated, and then like we need to solve problems, and we don't have enough people to do so. So we're always looking for more undergraduate graduates here. So I wanted to take this opportunity to kind of reach out for those of you that are interested in it. There's a form that you can fill out and stuff. I mean, you're in no way obligated to do so, but it's a nice opportunity. You'll get to experience enough deep learning. You will get the cool machines and stuff like that. Again, they're all paid positions and stuff like that. Fernandez has more details than I ever could on that, so that's why those form links are there. But I will be there at least for the next year or so. And as always, anyone in here is free to, that's my email, one of them anyways. You are free to reach out, you know. I always like helping people when I can. I can't promise that I will know the answer to every question, because I won't. But I can help point in the right direction or give you feedback and that kind of stuff. Which I think this leaves us about 10 minutes for questions, roughly. I may have talked a bit fast, but you know, happens.
So the examples you showed us with the tongue freeze and of course anything like Dolly, that also requires the machine to interpret language.
It does.
And so like how far is like natural language recognition come to like where it can basically mean without meaning?
We've gotten pretty far. I wish I had the paper on hand, which is to point out your meme without meaning. There is a very good paper that I cannot for the life of me remember, which kind of took that principle and how far can we understand the language, and we've gotten far. There are still times where it definitely doesn't understand what we're talking about, and English, I don't understand 100%, and I was talking in it for however many years, right? So there's just some weird rules and stuff, but it's gotten very good, and you can kind of see the language models on that side can hold up. It's understanding, it's translating that to the visual, which can be difficult. And the two fields are very different. Vision and kind of NLP do not mix well, at least right now. But it is something everyone's looking forward in the future to see how do we get these two to combine better.
Because as far as like natural language goes, I remember when having myself like a giant Jeopardy fan, so I was taking Jeopardy. And when IBM built Watson to play the game, they showed like in the early stages it had trouble recognizing the style of the clues were.
Yeah.
And then it just beat two of the best players in the game.
Yep. We have gotten far. I think like BERT is, and there's a variant of BERT which have gotten the farthest right now. NLP is not entirely my field, so those papers are a good reference, but really good from what I understand and really well ingrained. Longer form pieces of writing are much more difficult. It has trouble keeping context over long periods of time. Short sentences, it can do very well. Concise, probably get most of it. But like if I were to have a model do this entire, you know, workshop and keep track of everything I said and then be able to spit it back out to you, it would lose context to what it's going to.
How does it recognize sound?
It being what?
Like Siri, whenever you're talking to it, how does it know what you're saying?
How do you learn sound?
Repetition, I guess.
So that's one, right? Repetition. It's hear the same words. In fact, when you do Siri, it takes a while to get used to your voice to understand what's going on, right? 2, what is sound? It's just vibrations, frequencies, right? So words, vibrations, frequencies, those are all things that can analyze to say, hey, I've heard this frequency before. What did it closely relate to? Kind of put it to a dictionary, as you will, in Python. It's a bit more complicated than that, but that's baseline term, right? Understand a frequency, link it to something. Okay, I understand that.
So like in Shazam, does it have like a library of like frequencies of songs?
It has a database of stuff it's referencing, as well as some other ones. Frequency is other parts. So.
Is there any like particular factor that has led to, specifically on like the visual data generation front? It seems like recently like that field has been progressing very fast, or at least what's like exposed to us in the public. Is there any like particular factors that have led to that rapid increase from like all the way to now like making videos?
So one thing is hardware limitations has been rapidly growing over the last couple of years, right? We have more access to processing power than we ever did way back when. 2 is a lot of the math and stuff is now ingrained into the system rather than having to be done by hand, and all of these extra parts which you used to do hand labeling. You'd have to feed it in one by one. Now we can fill it in millions of images at a time. We can process over 7 different clusters all at once. So I don't think it's one particular factor. There are some definitely key ones, hardware. The CNN kind of architecture really helped. The transformer one also helped. But I would probably put it more on the realm of hardware than I would software, although they are both equally important, for sure.
For the research opportunity, is it okay if we come in with little to no knowledge of AI?
Yeah, I think going towards the fall, that's something we're looking at. Spring, I know we're looking for people with some more experience and stuff, but fall we probably will be. But you don't need to like only exclusively take AI, right? You can take a data thing, a data course or whatever. We just want some experience. And most of all, we want interest, right? If you want to do these things, and going beyond basically this slide, and just probably don't just come in and say, hey, I want to do AI, because that means a lot of different things. That could be so many different things. And obviously our lab particular is very good in computer vision. So we would look for more computer vision people, but that's, I think Dr. Ruan is looking for biological predictions and that kind of stuff. There are definitely faculty members on the other sides as well.
What is the biological predictions?
Take someone's medical history data, patient data, feed it through a network, and be able to tell whether or not they may or may not have something. So for example, one of my early projects, it was modeling a prediction based off of melanoma cancer, whether it was benign or malignant, right? And so you take a CSV of data, process it down into machine readable format, and then feed it through the network and ask, can you do it? I think in that particular instance, it was like a protein substance. And there's a lot of different ways you can do. I definitely wasn't the top of that challenge, but it was an active challenge going on at that time. So lots of cool challenges going on all the time. And the best part is anyone can participate. You don't even have to be in a lab. You can just, I want to try and participate in this challenge and see how far you get. Other questions? Comments, concerns?
You made any chess engines? Chess engines?
Have I made any? No, because I'm terrible at chess, and I don't want to release an AI in the world that is also terrible at chess. That would probably not go well for anyone. Unless you want a confidence boost in me, maybe I could throw something up. I'm pretty sure you could beat me. Other questions? Well, that's all I got. I appreciate, yeah, bless you. I appreciate everyone hanging out, taking the time. Hopefully it wasn't too hard to, I don't know what I was trying to say there. It's definitely getting late, I can tell. But hopefully you enjoyed it. I'll stick around. Actually, I don't know if there may be someone who needs to this room afterwards, but I can always stick around outside as well, so that's fine. Otherwise, good luck. Definitely get some sleep, or at least try. And, you know, blow the presentations away.